Hi, I'm Eddie Reyes from MindSight. This video is part 2 in a series that shows you how to take a simple Go web application and deploy it at scale in Kubernetes running in DigitalOcean. For this video, we're going to go over the Go application itself, and we're going to discuss how to containerize this application so that it can be easily deployed to Kubernetes. So first, let's take a look at the application itself. This is a very simple program that basically starts a very minimal web server that does nothing except listen to a single route, the slash route, and return a hello message as text HTML. If you're new to Go, look in the links on the description down below and take a look at the tour of Go, which is a great starting point for learning the language. So here we see the implementation of the handler, which basically sends back the message, and here's where we start the web server itself, and it's going to listen on port 8090. So let's run this server and test it quickly to make sure that it does what we expect it to do. So now the server is started, and it should be listening on port 8090, and let's run it in the background. And now we'll use curl to communicate with it and make sure that it responds back with the expected message. And sure enough, here we go. We get the message that we expected to see in text HTML MIME type. So the application works fine. Let's shut it down. And the next thing we need to do is to containerize this application. And in order to do that, you need to write a Docker file. We have a Docker file right here that we're going to take a look at. If you're new to Docker and Docker files, take a look at the links in the description down below. We'll link you to some guides that discuss the format of Docker files, and also to a guide that describes the builder pattern for authoring a Docker file, which is what we use here. The builder pattern is basically a way to optimize the size of your container so that it's as small as possible and contains no cruft except only your application. So this file can be read in two parts. This first part I've highlighted here is the builder container, and this container is concerned with using the Go compiler to take this program, copy it into the container file system, and building the binary for it. So this binary is going to be left in the image layer on the /app directory, and this second part is actually the specification for a different container, which is going to be the one that we will distribute containing the application. This container sources from the Alpine image. Alpine is a super minimal Linux distribution that is very tiny, and this image will have nothing except for our application binary. As we said, this server will be listening on port 8090, so we're going to go ahead and expose port 8090. And finally, it will do nothing but just run this app, kind of like we just did in the command line up here. Also of note in this file is this cgo enabled environment variable. Cgo enabled equals 0. This is on by default when you compile a Go application. The reason why we turn it off is because this Linux distribution is so minimal that it doesn't even have like a standard libc that you can dynamically link to. So this setting makes extra sure that this application will not try to dynamically link to anything. It will be a fully self-contained static binary with 0 dependencies. And if you don't do this, it will not start in Alpine Linux. So once the Docker file is all set, we're ready to try a build. So we're going to build this Docker image using the Docker command I'm typing here, and we're going to call this image Go sample, and we're going to tell it to build from the current directory. So the image has been built. It ran through all the steps in the Docker file, and the result is a Docker image called Go sample, and this will have the latest tag, which is the default tag name that Docker gives you if you don't specify it. So let's take a look at this image. And here you can see how big it is. It's 12 megabytes. As far as Docker images goes, this is pretty tiny. and it consists of not a whole lot except the application binary. So once you've built this image, the next step will be to distribute this image in a container registry. For this example, we're going to use Docker Hub. I'm logged into my Docker Hub account, and I have a repository corresponding to this Docker image I've just built with the same name, except that it's under my account. And this repository, as you can see by this lock symbol, is private. It is not shared publicly. When working somewhere, most of the time, you're going to be working on closed source software. And this tutorial, in addition to showing you how to deploy to Kubernetes and run this application eventually on DigitalOcean in their Kubernetes cluster that you created in the previous video, in addition to that, it's going to show you how to deploy private repositories that require credentials in order to download them. And we'll see how to set up those credentials in the next part of this series. But for now, we're going to show you how to take this Docker image that you've just built and how to copy over the latest revision to this container registry for distribution. So the first thing we'll do is we'll create a local tag. We're going to use docker tag, and we're going to say tag gosample latest, which we've just built up here, and give it a tag with the same name that exists over in Docker Hub, and we're going to give this a tag called demo. When you create these tags for distribution in the Docker Hub registry, it's important that you give each change a unique tag name, because Kubernetes does not work well when you're doing when you're deploying new changes and you keep using the same tag name. Kubernetes treats these as immutable names, and if you change your code and you distribute a new version to the container registry, your tag name should be unique. It should be different every time. In this case, we're going to use demo. It's a tag name that we haven't used. And we're going to push this up to the Docker Hub. If you have never used the Docker command line on your system to deploy to Docker Hub, you will have to run Docker login. And Docker login will ask you to enter your username and password that you've already set up for Docker Hub. I've already done it on this system, so I'm not going to do it again. I'm just going to go ahead and push this tag that I've just created in the previous command. And this is going to send it to Docker Hub. So the image has been pushed, and if we reload, we'll see the demo tag that we've just created. So we now have all the prerequisite steps complete in order to take this application and deploy it to Kubernetes. In the next video, we're going to cover that process and all the configuration that you need to do in order to get this up into that Kubernetes cluster you created in part 1. Thank you very much. Please subscribe to see more content from us, and have a nice day.